Hello everyone, my name is Vishal Shrivastav. I am a student of Civil 4th year at Faculty of Engineering and Technology, University of Lucknow. I am present here to present my seminar on the topic failures in rigid payment. Here are the table of content. Introduction, failure of rigid payment, types of rigid payment, case study, conclusion. Introduction, rigid payment are a type of road or pavement structure composed of a rigid layer, typically made of reinforced or unreinforced concrete. Rigid pavement are constructed using a rigid slab system that distributes load over a wide area. Failures of rigid pavement. Failure in rigid pavement, cement concrete pavement can be identified by formation of cracks on pavement surface. Failure in rigid pavements can occur due to various reasons, impacts, the structure, integrity, and functionality of the pavement. The two prime factors responsible for the rigid pavement failure are use of poor quality materials, inadequate stability of the pavement structure. Types of failure in rigid pavement: joint spelling, faulting, pumping, shrinkage cracking, warping cracks, punch out, linear cracking, corner break, polished aggregate. Joint spelling in rigid pavement. Excess compressive stress can cause restoration in joint called as the spelling. It is breakdown of slab near edge of the joint due to excess compressive stress. Normally it occurs within 0.5 meter of the joint. Causes of failure: excessive stress at joint due to wheel load, freeze through cycle, faulting alignment of incompressible material below slab, poor quality control of construction technique used in pavement. Remedies: spelling less than 75 mm 3 inches from the crack free can generally be repaired with a partial depth patch. Spelling greater than 75 mm 3 inch from the crack may face indicate possible spilling at the joint bottom and should be repaired with a full depth patch. Faulting in rigid pavement. Faulting in rigid pavement is a vertical displacement of height differential between adjacent concrete slab in a road or pavement. The difference in elevation between the joints is called faulting. Faulting is measured by specialized equipments like profilometer or straight edge. Causes of failure: settlement of pavement due to soft foundation, erosion of material under the pavement, heavy load and replaced traffic load can cause the concrete slab to settle unevenly over time, leading to faulting. Remedies: grinding the concrete slab to level uneven slab, especially in case where rigid pavements are constructed using a rigid slab system that distribute loads over a wide area. Pumping in rigid pavement. Pumping is the ejection of material by water through joints or cracks caused by deflection of slab under passing loads. When soil slurry comes out, it is called mud pumping. Causes of failure: infiltration of water through the joint, cracks, or edge of the pavement from soil slurry. This distress is caused due to the active vehicle loads coming over the pavement in a repetitive manner. Remedies: properly sealing joints and cracks in the pavement helps pavement water and fine material from infiltrating and being forced out during traffic loads. Installing effective drainage systems such as French drain or subsurface drainage pipe helps to remove excess water and minimize the risk of pumping. Strengthening the sub-base layer by using sustainable materials such as well-graded aggregate or stabilized soil can help distribute load more evenly and reduce the potential for pumping. Shrinkage cracking. Shrinkage cracking is common issue in rigid pavement and it occurs due to the natural process of drying or and shrinking of concrete. These cracks may form in longitudinal as well as transverse direction. Causes of failure. When concrete curves, it loses moisture. As the moisture evaporates, the concrete shrinks, causing initial stress that can lead to cracking. Improper mix property proportion, such as excessive water content, can contribute to increased shrinkage upon drying. High temperature, low humidity, and wide condition can accelerate the moisture evaporation process, leading to increased shrinkage. Remedies: using proper concrete mix design with admixture or supplementary cementation material can reduce shrinkage. The water to cement ratio is appropriate for the mix design can significantly decrease shrinkage potential. Using of shrinkage reducing admixture or fibers in the concrete mix to minimize shrinkage cracking. Warping cracks. When joints are not designed properly against hot weather, it prevents explosion of concrete slab and therefore result in development of excessive stress. The stress causes formation of warping cracks. These cracks are often found at or near transverse joints. Warping cracks, also known as curling cracks, are a specific type of distress that can occur in rigid pavement. Causes of failure. Differential temperature change across the pavement can cause the slab to expand or contract unevenly, resulting in warping. Variation in slab thickness or inadequate reinforcement can lead to differential moment and contribute to warping. Remedies. These type of cracks can prevent by providing proper reinforcement at the longitudinal and transverse joint. Implementing proper joint design and spacing along the well-designed load transfer mechanism can minimize the effect of curling and warping. Punch out. Pavement punch out occurs when the concrete slab beneath the pavement experiences excessive downward deflection due to heavy or repeated loading, such as farm trucks or other heavy vehicle. This leads to formation of a hole or depression in the pavement surface, often resembling a punch mark. Hence, the term punch out. Remedies: preparing the damaged area by filling it with suitable materials like high strength concrete or performing a partial or fully depth replacement depending on the severity of the damage. Linear cracking. This type of failure in rigid pavements divides the slab into two to three pieces. These cracks can vary in length and width, and they are commonly distressed in both flexible and rigid pavements. Causes of failure: heavy load, exponentially when applied repeatedly over time, can induce stress on the pavement surface, leading to the formation of cracks. The cracking due to thermal gradient and moisture loading. Remedies: cracks ligand can use to seal the linear cracking. If linear cracking leads to panel cracking, then the pavement is restored by full depth repair. Here are the case study. For project name was NH160 from Ahmednagar to Kinetic Chowk to Vasudev Path. Place was Maharashtra. There are two treatment repaired crack PQC panel. First is to replace the PQC panel and second is to fill the cracks with exploratory based grouting material. Conclusion: the major factor affecting pavement was free water trapped within the pavement section. Most of the road material maintenance work are done by emergency basis. As a result, proper quality control is not always possible. Conclusion: in conclusion, the study of failure in rigid pavement is essential for ensuring durable and long-lasting infrastructure. We have explored various types of failure such as cracking, faulting, and spalling, each having its distinct cause, ranging from inadequate design to environmental factors. Understanding these failures not only helps in diagnosing the problem but also aids to implementing effects maintenance strategies and innovative design approaches to mitigate these issues. Through proper conclusion practices, regular maintenance, and the application of advised material, we can significantly reduce the occurrence of pavement failure, prolong the lifespan of roads, and ensure safer travel experience for all.